Okay, so we are starting today. Like there are 5 to 6 classes in PNC. Out of that, this is first class. In the first class, what we're going to do, we're going to do like introduce the PNC properly. So, Aryan, there are two things. One, selection. Another one is selection plus arrays. Agree? So selections means like suppose we have 3 people, we have to select 2. So order does not matter. Where the order matter, that is selection plus arrangement. That is called combination. No, this is called permutation. Sorry. And the only selection is called combinations. Agree? Just like I have A, B, C. How many different ways I could select 2?
Many 6.
Hmm?
Uh 3 or 4.
How many ways I can select 2?
4.
I can have A, B.
AB,
I can
AC,
take AC. I
and
can
BC.
take BC. That's
That's all
it.
three.
Only 3 methods. And how many ways I could select and arrange? Just like I have seating arrangement of 2 seats I have labeled only, and there are 3 people. I want to make them sit into this, and I count how many different ways I can make them sit in those two of these 3 people. So first step is you select. Okay. What is the first step? Select. So you have to select 2 because you have constraint of selecting 2. So what is the way of selecting? You can take either these selections ways are there. If you take A, B and try to put here, it will be A, B is one seating arrangement and B, A is different seating. Okay, so this is 2. The other one also will have 2. The other one also 2. So 2 into 2 into 2. That is the 6 different arrangements. Agree? But selections are only 3. So when order does not matter, when order matters, that is the order matters where that is called
Permutation.
permutations. Where order does not matter,
Combination.
that is called combination. So they won't you directly whether it is permutation or combination. You have to find out. You have to figure it out by looking into the questions. If I have A, B, C only, I'll say how many different seating arrangement I can do. Like how many different ways I can select person.
So that's
I can select. I am not saying anything. How many different ways I can select.
select. Okay.
Okay, so I can select first I differentiate how many I'm selecting. 1
Mhm.
or I'm selecting 2, I'm selecting all 3. Okay, so if I select 1, then only like these 3
B or
can
C.
you can take A or B or C. If I select 2, I can have like A, B, B, C, A, C, A, C. And if I have to select, then only one way, A, B, C.
Yeah.
So if I'm saying, okay, I have unlimited seats, I want to make them sit, and there's no constraint whether selecting 1 or 2 or 3. How many different ways I can do setting array? Yeah, how many different words I can form by using A, B, C? This is the appropriate example. Read how many different words I can form. I can form 1-letter word, 2-letter words, 3-letter words. Agree? So 1-letter one only 3 options are there. 2-letter one word will be 6 options. 3-letter word will be 6. How 6? If you take A, then you can take B, C. If you take A, you can C, B, C, B. If you take B here, then
AC.
AC, then if B here, then CA, and then here C, then BA, and C, then AB. These are 3-letter words. And 2-letter words, you can have AB, BC, and AB, and then BA.
Yeah.
AC, then
CA.
CA, and BC,
CB.
and CB. So these, and then 1-letter word only A, B, C. So how many different words I can form by using A, B, C? Repetition is not allowed. Okay. So 3 and 6 and 6. So 3 plus 3 plus 3. So in the permutation combination, what matters? How many you're selecting? You can select few, you can select all. Okay, and whether you are doing permutation or combination, that you have to differentiate. And also to differentiate whether order is there or not. Like whether you have to take all or you have to take few. Yeah, something is repeated or not repeated. These a lot of constraints are there that you can put into this. So okay, see, suppose I have like A, B, C, like see, what is n factorial? Let us start with like these are the counting. So can we do it by proper maths by using this? So what is n factorial? Anvika, do you know n factorial?
Yes, sir.
what it is, n minus 1, n minus 2, it goes till 1. So can't, like, what is 7 factorial? Isn't 7 into 6 into 5 into 4 into 3 into 2 into 1? What is that? Isn't this is 6 factorial? 7 times 6 factorial.
Mhm.
If you have like 7 times 6 times 5 factorial, then you have 7 times 6 times 5 times 4 factorial. So you could expand what is your requirement. Okay.
Yeah.
So if you have 7 factorial, you can write 7 into 6 factorial. You can write same as 7 into 6 into 5 factorial, depending on. Similarly, if you have n factorial, you can write n times n minus 1 factorial. You can write n minus 1 and n minus 2 factorial. Okay, so you can do whatever you want. So you can expand it the way you require. So this is the factorial. So a lot of algebra you can do by using factorials. Now there is NCR and NPR. NCR. NCR is n factorial divided by n minus r factorial into r factorial. Okay, what it is? N factorial divided by n minus r factorial times r factorial.
This
What
is
you-
for combinations, right?
This is like for permutation, the combination. Sorry, how many? See, the significance of it, like use of it, is like n. Like suppose 7 objects are there, you selecting. Agree? So this is for combination. Rightly you said 2 you selecting. So out of 7, and constraint are there. There is no repeated here. 7 are there, all different. This is used only for different. If there's 2 things common, then you have to select like the 7 are there and 1 or 2 are like same, and then you selecting 2, 3, then the things get changed. Okay, this is only used when the all ABC is like this is used for A, B, C, D, E, F, okay, G. So it is not used for if 2A are same.
Mhm.
Okay, so NCR is n factorial. So just like typically I want to see if you have NC0, what it would be? Can anyone tell me? It is n factorial divided by n minus 0 factorial into 0 factorial.
Yeah.
Rule says this. What is 0 factorial?
Yeah.
No, if this you put in denominator 0, you gone, no?
Mhm.
What is 0 factorial?
So wouldn't the answer of NCR be 1?
No, in this case, NCR is 1 because 0 factorial is 1. So n factorial is equal to n factorial. Remember that 0 factorial is 1. There's
Why is that?
because 0 factorial they defined as 1. There is not like some rule. So this
Okay.
cancel out to 1. Means if you have like n object and you want to select 0, none of them, then only one way around. That you don't have to select any. Okay. What
You
is
select all.
no. So NC1. So NC1 is n factorial divided by n minus 1 factorial times 1 factorial. So this is n minus 1 factorial divided by n minus 1 factorial. Because I told you you can operate whatever you require. This cancel out. This is n divided by 1, which is n. Okay, means if I have A, B, C, D, and I'll say select one out of that, so you can select either A or B or C or D. So how many different ways you have? 4 ways. So if you write here 4C1 is 4 ways of selections. Okay, order of selection does not matter because you're selecting. Okay, so NC2 if you want to get, then it says n factorial divided by n minus 2 factorial times 2 factorial. So this one is n minus 1 factorial divided by n divided by 2 factorial into n minus 2 factorial. So this, no, something I have written wrong. I had to write one more here, n minus 2 factorial divided by n minus 2 factorial times 2 factorial. This cancel out. So n minus 1 or 2 into 1. So out of n objective is selecting 2, how many different ways you have? N into n minus 1 by 2.
Yeah.
So just like 10 ways if you're selecting 2. So rather than writing all of that, you write 10 into 9, 2 into 1. So 45 ways. If 10 different objects are there, you're selecting two. How many different ways you could select it? 45 ways. And remember that NC3 is again n minus 1, n minus 3, n minus 2, and n minus 3 factorial divided by 3 factorial into n minus 3. So this cancels out. It will be n minus 1, n minus 2 over 3 into 2 into 1. Okay? So these are the ways that you select. Okay, so we can generalize it from here. If NC0 means if you have to select 0 object from n, then one way. If you select one object, then one, like n ways. If you select two objects, then it will be n minus 1, 2 into 1. If you want to select three objects, then it is going to be n minus 1, n minus 2 over 3, 2, and 1. And this keep going up. If you want to select 4, then write like here n minus 3, n minus 2. Okay, so that is the shortcut of like selecting. And remember, if you have to select n out of, like you have to select r from the n, and r is very close to n, then you could write n minus r both are same. Means selecting, suppose 6 may say one object would be same as 6 may say 5 objects. It's leaving, you can think that way. I'm not taking one. Like how many different ways I can leave one. It is same ways we select one. Okay, so this is the fact that you can remember it whenever you have to evaluate. Suppose 10C9, so you can write 10C1, and that is the fact which 10. So if you want to select 9 out of 10, then you have 10 ways one. Okay, or you leave one out of the 10, then 9 ways one, which is not getting selected. How many different ways the particular things are not getting selected. So that also you can use it. So this is NCR selections. Now, see, if you have NR object, just like your A, B, C, D, I am saying just form two letter. How many different two letter words you can form? So in this case, you first select two, then arrange them.
I think 6.
So selecting out of 4, 2, arranging 2 out of 2 is 2 factorial. Arranging always whatever number to whatever number is like that much factorial. So that is called 4 factorial divided by 4 minus 2 factorial times 2 factorial into 2 factorial. Okay, so if you simplify that, I think that would come as 6. If you select 6, there are 6 ways of selecting. Arranging is 2, so that would be 12. Okay, so that is directly you can do NCR into R factorial is NPR. Means if you want to select R object from the N objects, then how many different ways you could select this and then arrange them by R factorial. So that is combined selection plus array. Like I said, find two letter words from using these. So first you check constraint, is there like A, B, C, D, all different? Yes, all are different. Then selection plus arrangement is going to be NPR. Okay.
Sir, but can't you cancel the 2 factorial?
You do
So
better.
then
4 into, listen, 4 into 4, like 4 into
2
3,
factorial.
2 into 1 over. Okay. So this is 2 factorial into 2 factorial. Understand? Into 2.
And then on,
So this
and then
cancel.
on, yeah.
So that
So,
two only, 12 only, no?
so technically, sir, NPR is just n factorial upon n minus r factorial.
No, NPR is NCR into R factorial. Means if you suppose an object, may say you selecting R and arranging R. So selecting R is NCR and then arranging those R is R factorial. Like you have to 10, you select 3, then arrange those 3. So this is selection plus arrange, that is called 10P3. Okay, So this was selection method. This was arranging for each selections.
Mhm.
Okay, just like if I have A, B, C, I want to like select and arrange two. So first I select. So first if I select A, B, those are two. Different way of arranging is 2 factorial. So this would be 2, 1. Because this is 2 and this is one way of selecting. So this A, B, and then you take B, C. That is also 2 ways can be arranged. Then C, A, that is also 2 ways can be arranged. Okay? That's how it is. So you can do this way. Yeah, you understand that?
Yeah.
So can we try few questions from this? So just like this, first question. List the permutation symbol W, this. Permutation means the
Range.
you selecting one or arranging one means only selections. No, arranging will not differ from selecting two and arranging, then every time it get multiplied by 2 factorial. All are different. Agree. The 3 then you write the same way you have to do. List the permutations of symbols of A, B, C, D, and E. Yeah. How will you do with this one? C.
C3. Yeah.
How many ways can 5 different books be ordered on shelf? Tell me how many selections we have. One only because you're taking all of them. Okay, so 5 out of 5 you arrange, then 1, 2, 3, 4, 5 places are there. So first place can be filled by any 5 books. Second, 4 books. Third, 3, 2, 1. Isn't this is 5 factorial?
Mhm.
So when you arrange and select 5 out of 5, then that is going to be what? 5 factorial. Okay. Find the number of permutation there are in the symbols in 3 at a time. So that is same way. Na? You first select 3 and then arrange 3. So selection plus arrange, you directly write NPR. So in fact, NPR is equal to n factorial divided by n minus r factorial. Because r factorial was there in CR and then r factorial multiplied, that got cancelled out.
So that's what I was saying before only. They'll get cancelled out.
No, that is why it become in this, no? So you
Yeah.
cancel r factorials over there. Okay. So now let us take some technical questions. This question that we can see it. 3-digit number can be formed using this. Tell me. You want to form 3-digit numbers and you can use how many times you want to use a digit. 3-digit. Okay. So you have 3 places to fill. So one place can be filled by any of that. So 4 ways. So order does like how many times you want to use it. Then also this by 4 ways. This also 4 ways. So how many ways it is? 4 raised to 3. Which one is what? 64. So when order does like when repetitions are allowed here. So what did I tell you? The formula is valid when repetitions is not allowed. So here repetitions is allowed, then every place can be filled by like how many numbers you have. So now if you take ones, then you have 4 places. Oh, then this place can be filled by how many different ways? 5, no, 4. This can one gone because repetitions is not, then 3, then 2. Okay. So that's how it is. So now if I use permutations for that, then what I should do? I want to use permutations. Out of 4, you have to select 3 and arrange those 3. Agree? So this is 4C3. Okay, so 4C3 is what? Like this is 4 factorial divided by 4 minus 3 factorial into 3 factorial times 3 factorial. That 3 factorial cancel out. This is anyway 1, so 4 factorial. Okay, so isn't this is 4 factorial?
Yeah.
Okay, so selection plus arrangement, you have to see when you can apply, when you cannot apply. Now you're moving forward. These kind of questions, can you see like this? Can you do question number 8? Can you try by yourself? So like the alphabets we have given into order, how many different permutations are there? Tell me how many different permutations are there? Means they're not saying anything.
Five.
So 5 factorial. Okay, now how many permutations ends with C? Means you fixing C's place. Ends with C means you fixed it like that place is fixed. C's place is fixed here. The rest you can change. Now 5 remains. 5 out of 5 you have to, 4 remains. 4 out of 4 you have to fill. So 4p4. 4p4 means 4 factorial. Okay. So if you want to like now 2 places are fixed here. So this can be filled by 3 ways. This can be filled by 2 ways. This can be filled by 1 way. So 3 factorial. Agree?
Mhm.
Now D is saying how many ways permutations begin and end with a vowel. Okay. So you tell me. So begin and end with vowel.
A and E.
So A, E here, and other way around E and A here. This is 3 factorial. So 2 options are there for 3 factorial. So 3 factorial into 2, what it is?
6 or 12.
Now you try this. I'm just pausing video for 5 minutes and I'm on. If you want to do this, consider later this 5 alphabets. These blocks are placed in the row. How many different positions? There are no restrictions. Means row having 5 place, and you have to select 5 out of 5. That you have to assume. Agree? There is no place choice. 5 out of 5. So 5 out of 5 is what? 5p5 is 5 factorial. 5 factorial means 5, 4, 3, 2, 1. And you can find out. Row ends with, now see, starts, you don't know. But you fixing these 2 positions, that is R, the other one is Q. So you have choice only for 3 positions. So that 3 position will be filled by 3 factorial because there is no choice for that. Agree? The row begins with S means you fixed here and you end here. So each may 3 factorial.
So 6.
Okay.
Yeah, even.
Now the question number 11. The 4-digit numbers is made up using this. Okay. At most 1 each. You have to use how many different numbers, there are no restrictions. So tell me, isn't 6 factorial? Okay, the number must begin divisible by 5. To be divisible by 5, it should end by either 0 or 5. So if you fixing the unit place.
So we don't have 0, it's only ending by 5.
तो ending मतलब fixing 5 ना, you don't have the options for that. So only one way is around. The remaining 5 can be filled by 5 factorial.
Yeah.
So answer is 5 factorial.
Not 5 factorial, sir.
Why? There are
Sir,
6 beta. 1, 2, 3, 4, 5, 6, and you have fixed 5. Remaining
but
5.
sir,
हाँ बेटा.
sir, you have to create a 4-digit number.
अच्छा 4 digit.
Yeah.
So I didn't read it. So the number must see how many different can be the 4-digit number. It's in beginning only 4 digits. So out of
Yeah.
4 digits, you fixed 1 digit, no? 5.
Yeah.
Now 3 you have to select out of remaining 5. Agree?
So it'll be 5p3.
5p3. 5, 4, 3.
Hmm.
Okay, so for this, how many choices you have? 5. For this, you have 4, you have 3. That could be like done by 5p3 has been selecting 3 out of 5 and arranging them here.
Yes, sir.
Okay. Now the number must start 6 and end with 2. Start with
6 and end.
Start with 6 and end with 2.
So then 2 numbers.
So then, sir, it'll become 4p2.
Yeah.
4p2. Perfect. Now this is done now. Now this is like they'll increase little when you go ahead. The 3-digit numbers are this. There's no restrictions. What you have to, how many different number can be formed if 3-digit number? You want to find there is no restriction and you have to form 3-digit numbers. Okay. So when
So
these
there
are
is
the
one
case, you have to always start with this leftmost side.
So there is one restriction.
Okay. There's what restrictions we have?
It cannot start with 0.
That's what it is. So see how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. This place can be filled by 7 ways because 0 cannot come here. If 0 comes, then it won't be like 3-digit number. Then this again can be filled by 7. This again can be filled by 6. Actually 7, 7, 6. Okay. Now what about this? The number must ends with this or this. So for unit place, how many choice you have? 3 choice. Okay. So now this place, how many choice you have?
The unit.
You can't take 0 here.
Yeah.
And then this place, if you can't take 0 here, okay? If you take in suppose 2 here, you can't take 2 as well, no? These 2 you can't take here. So whatever digit you take here, that you can't take here, and 0 you can't take. So how many remains then? 6.
6. Yeah.
And for this 6. The answer is going to be 6 times 6 times 3. Anyone, any problem on that? So always you fix this place and this place. Okay. Okay. Now they're saying the number must end in 0. End in 0. So like you place here 0, then it's like like 7 place 6, 7, 6 because 0 you fix. The number must be even. That is very good question. What to do to number must be even? Isn't you just add this plus one more constraint that 0 coming here.
Yeah.
If 0 coming here, then this can be 7, this can be 6. So 7 into 6, okay? Plus whatever answer you got into B. Okay. The 14th. Okay. So what are you doing here? What did they say? How many 3-digit number can be made by using this? At most once if there is no restriction. Tell me.
5 factorial.
No, if there is no restrictions. You have to make 3-digit. So this place can be filled by what?
Any number.
Hmm?
It doesn't say non-zero. So
But it can't be 0. But 3-digit, then it won't be 3-digit, no? Then
Okay,
if you place
so-
a 0 here, so 4.
Yeah.
Then remaining 0 also includes these anything can come here and then 3. Okay. Now the number must be less than 500. So when you say number must be less than 500, so what options you have for this place? Either one or
1, 3.
that's it.
Yeah.
So 2 options for that. For these, you have 4 options and 3 options. Agree? The number must be even and greater than 300. Tell me. Even and greater than?
So the last 3 then. I mean last units place is 8.
Even and greater than 300.
Units place is 8 or 0 and the first.
What is the condition for being even?
Yeah, even like the last number is.
And even and must be greater than 300.
Yeah.
So with this place, first you fill it, it will be 3, 5, 8,
Mhm.
3 ways, the remaining 4 ways, no, anything, and then the other one is 3 ways.
Yeah.
Understand?
So, but it can't be like 8 and 8, right?
Acha, haan, that has to be even also, no? So you first put constraint here, any 3. So this is like good question now. So if that question, if you get 3 here, then this can be filled by how many different ways? anything you can,
Yeah.
but even you want, then you fill second place. If 3 is here, what you can take is 0 or 5, no?
Mhm.
If this 3, this 2, then remaining how many letters? 3, so 3. So 3, 2, 3.
Okay.
Agree? But if this is 5, then again same thing.
Mhm.
Okay? But if this is 8, then you have only, you can put here 1 0, no?
Yeah.
And then remaining here. Okay, so this like tricky question that you have to like work on. Now see these questions 15. In how many ways can 5 different books in arrange on the shelf if X and Y are together? X and Y are together.
Together or
So if X, Y are together, means what actually you're doing. See, there are 5, suppose A, B, C, and X, Y going to be together. So how many different books you those will go together? Agree? So how many, what is the, like what, how many ways they can move their position? In 4 factorial way.
yeah.
Okay, then they can flip their positions.
Order. Yeah.
So 4 into 3 into 2 into 2. This is the way how it goes. Now, how many ways they're separated? So find out all possible ways. Okay, find out all possible ways, then subtract when they're together. What are the all possible ways? 5 factorial, because 5 book were there, minus whatever answer you got in it.
Yeah. 40 minus 1.
Understand? Now, 16. 10 students sits in a row of 10 chairs. Okay. In how many ways can this be done? So 10 students are there, no? So 10 factorial.
Yeah.
Okay. The student A, B, C instead of sitting together. So if you want them to be together, what will do? You have A, B, C together. Remaining like 7 are there. So total are 8 factorials.
Yeah.
Now these can flip their position. So 3 factorial.
Yeah.
Okay. And when they are not together, what will you do? Then you subtract 10 factorial minus this.
Yeah.
Because when there's no restriction, then when they're together and you subtract, then you'll get 10, they are not together. Agree? Okay.
Six
Hmm?
factorial.
Kitna?
6 factorial.
6 factorial. Second, at least one vowel must be
No,
used.
it's 4 letters, not so
4 letters, no?
it won't be 6.
So all are different.
Yeah.
So you can use A and you won't use O. Okay. If you want to use one, then how many are there? 1, 2, 3, 4. 3 letters. What did you say? How many letters?
4.
4. So 3 more you have to select out of 4.
Mhm.
So what it would be? Out of 4, kya? Oh, gone, no? How many remains? A you're taking, O gone. So how many remains? A you taking, O gone. So 3 more you have to
3.
select.
Yeah.
So 3 out of 3 you have to select. No? So one way.
There was also D.
No, so there are 4 other.
Yeah, there are
Com-
4 ways because it's 6 letters.
And it's 6 letters. So O you not taking, A you have taken.
Yeah.
2 gone. So 4 में 4 ही बचा. 3 you have to select. So 4 C3. Agree? Total become 4. So 4 factorial.
Yeah.
So what you'll do? 4 C3 into 4 factorial is the one way around there when you select plus arrange. When you take A, when you take O, then it's same.
Okay.
When you take both, then only you have to select 2 more. So O, A, then selection is 4, may say 2 only. And then arrangement is 4 factorial.
Okay.
Understand? You add all of them. So this or this or this. Understand?
Yeah.
The 2 vowels are not together.
So ONA.
Hmm?
ONA are not rows. You just take them when they are together, subtract it from the total.
But okay, so this 18th. So guys, did you get this? Got it, guys? और देखते क्या है इसमें से ये तो हो गया now this see look into these kind of questions so you using these different letters and you have to form a different word by using like see but it's how many permutations are formed using all of them. So when you have to use all of them and there is repetitions. You taking all and there are repetitions. So you have different ways of doing it. Just like if you have A, B, B, C, D, E. So how many different word you can form? If you take one A, like 1, 2, 3, 4, 5, 6, 7. So 7 factorial out of that, these two are same. So 2 factorial, these two are same, then 2 factorial. That's what you have to do. So how many same you have that much factorial you have to divide type of, like you have to separate type of also. Okay. Which is start with A and end with S. Okay, start with A and end with S. End with S. Agree? So out of that, like what remains? Start with A. So how many are there now remaining? This A gone and this S gone. So now you have 1, 2, 3, 4, 5, 6. So 6 factorial. Out of that, you find out those are similar one. You have to find out and then divide it. Like 2, like now find out how many are same. Like L, 2L, 2U, 2C's are there. So that you have to divide it by. So 2C's, 2L, 2 U's are there. So that's how you have to divide it by. Okay. So now see, they said start with C and end with L. So repetitions is now not there because you have fixed one C position, one L position. So only one repeating is there. That is that number is like U. So you have to do that factorial by U. Okay. Can you just try these two questions? Uh, okay. How many permutations are there if you use A, B, B? Isn't this is 4 factorial divided by 2 factorial times 2 factorial? Okay. So if you use this, then you can like write here 1, 2, 3, 4, 5, 5 factorial divided by out of that 2 factorials and 2 factorials. Here also you can do same way. Like you understand this is like this we did it, you understood. Riddhi, can we solve this? You have given 9 CK, agree? Is equal to
Yes, sir.
4 times of 7K minus 1. So what is 9 CK? Is in 9 factorial divided by 9 minus
K factorial.
times K factorial.
K factorial.
4
Yes.
into 7 factorial divided by 7 minus K plus 1 factorial. Even K minus 1 factorial.
So why K plus 1?
Because you subtracted and then you put minus K minus 1, then that would become plus. Agree?
Okay.
So now, anyway, you to solve it, you have to remove the K factorials.
Yes, sir.
So how will you remove that? Like anyhow, how will you solve that? Tell me. बोलिए मैम, मैं हंसरा से बोलूँ, बोलिए. I'm good, tell. या आ जाओ. आ जाओ. Done. ठीक. Okay, so you since anyhow you have to remove all the factorial before solving it. To remove factorial, here is 7 factorial. You have to get 7 factorial this side. This is 9 minus K factorial times K factorial. So if you expand it right, K minus 1 factorial, because K minus 1 factorial is the other side. 4 into 7 factorial. K1 8 minus K factorial into K minus 1 factorial. ठीक है, this and this cancels out and this cancels out. 9 into 8 over 9 minus K factorial is equal to 4 over 8 minus K factorial. Now again you don't want factorial to be there. So if you open this up, then you write 9 minus K, then 1 reduce it to 9 minus K minus 1 factorial. So this become 8 minus 1 factorial. Then right side you have 4. So now this you replace it by, and then this cancel out with this. So you'll get 9 into 8 over 9 minus K is equal to 4. So 4 also cancel out by 2. So 18 is equal to 9 minus K. कुछ गड़बड़ हो गया क्या? देखो रिद्धि क्या गड़बड़ कर दिया, कुछ लिखना भूल गया क्या? इधर K था ना, I didn't write. This K also there. Okay, times K. Now you solve it by move one side and solve it. Understand or not?
Yes, sir.
Perfect. So this is your understanding. Now, can you do by yourself this? This you don't have polynomial, you haven't done that. Can you do how many different teams 7 can be chosen in training of 15 spots? Batao, what will you do here? Isn't this is 15C7?
Yes, sir.
There's no restrictions, no?
Yeah.
Because you're selecting only this.
So 1 and 2 will remain constant, and then 5C3 will be the number of selections possible. So answer will be 5C3.
ठीक है. This 14.
They're commenting. So for no restrictions, then it will be 14C3
Yeah.
because it can be any amount of male and female members.
Yeah.
And in B, so for 3 males, then only
Then it's just 8C3, right?
Male, you fixed it, no? How many males are there?
6. So it would just be 6C3 instead, right?
Hmm.
Sir,
If there are no restrictions, how many different committee can we choose? If 3 males, like see if that in see now what information you have as of now? Committee of 3 people you have to select, and 8 males are there, and like 6 males and 8 females are there. Agree?
yeah, so
And
the first one
you have
says,
to select 3. No. There is
yeah,
no
3.
restriction how many different committee can be formed. So see, there is no restriction. So there are total 14. Agree?
So I already said that,
14 C3.
14C3.
So you select 3. Now this
So the
committee has
next one,
2 males. No, so 6C2 and
3 males,
and
sir.
नहीं there's ये वाला बोला 2 males ना बेटा.
Acha, I thought
6
we're doing
में
the
से
one
2
before.
males and 8 में से 1 female. Agree?
Yes, sir.
Sir, I'm sorry. In the beginning, I disconnected for some time.
Yeah.
How do we calculate C3, C2, P3?
Okay. So see, if you wanna sell, suppose you have to like 5C2, you have to calculate. 5C2 can be written as this also. Look at this number, write 2 into 1. To start with this and go till 1. Reduce every time by 1. And 2 numbers are there, then write 5 and 2 into 4 only. From top number to like how many numbers you have. So that would give you 10. No? And actually formula is 5 factorial divided by 5 minus 2 factorial times 2 factorial. Agree? This you if you NCR P like 5 P2 if you want to calculate, then 5 factorial divided by 5 minus 2 factorial. That's it. Or 5 P2 would be 5 C2 into 2 factorial. Agree? So that you can do.
Okay, sir.
Now this 1 male and 2 female. Same way now. Out of 3, so 3 you have to select 1, so 3C1 into 8C2. Agree? All 3 females. So out of it you have to select 3 female, and out of 3 males you have to select 0 male. What happened? क्या हुआ अरुण? Okay, we'll help you. बाबा पढ़ाने दे बेटा. Come. अच्छा, try 15 by yourself. The committee of 4 singers is chosen from 7. ठीक है? And 9. Find the number of where the selector. There is no restriction. So again 11. Like see. 16 C4 because you're selecting 4 out of 16. 9. Okay. So 7 plus 9 C4. ठीक है? It must contain 2 and 2. Okay, so here 7 say 2 you select and 9 say 2 you select. And this is good question. It must contain at least 2 this. So at least 2 matlab 2, 3 or 4. So if you select 2 out of like 9, so then you 9C2, the remaining 2 you select from 7C2 or 9C3 into 7C1 or 9C4, 7C0. So if your 0 here means 1, this full value is going to be 1. Okay, so now you can evaluate it. Let us evaluate together. So this 9 into 8, 2 into 1 into 7 into 6, 2 into 1 plus 9C3. So 3, 2, 1, 9, 8, 7 into 7C1. So 1, 7 plus 9C4. So 4, 3, 2, 1, 9, 8, 7, 6. 4C0. So this become 1, 1. If this is 0, it's 1. So these are the ways you add them, then you'll get number of ways of selecting them. So the question will not be direct for this, question will be indirect. Okay, so that's what it is. The permutation combinations are like that. Now see, can you try question number 17? Exactly, 2 doctors and one dentist. So it's fine. Exactly 2 doctors. That is our formula. At least one doctor or dentist. So when you say at least one doctor or dentist, then you combine these two. So 9 may say you have to select at least one. So 9C1. Then you can the committee of 5. So you can have 9C2. Then 9C3. 9C4, 9C5. So committee of 5. So remaining you have 4 you have to select here from remaining nurses or what 7 nurses are there. So 7C4 and here 7C3, here 7C2, here 7C1, here 7C0. Understand, guys? Okay, so tell me how many diagonals does the 20-sided convex polygon has?
So what does convex polygon mean?
Convex matlab it is something like that. It is not like does not have like this and this like this. The angle has to be below 180. Agree? Interior angle has to be below 180. Okay, so to form a triangle, what is required? Tell me. If I want to form a triangle, what should I do? Just like take a suppose four-sided. Look, just like take a four-sided. Just like this is square I've taken. So how many triangle I can form? Tell me. If you're A, B, C, D. Tell me how many triangle I can form if I join or do something.
But sir, for that question, it says how many diagonals does a
Okay,
20
diagonal, sorry. So how many
Yeah.
diagonals it has? Tell me.
So 170.
Hmm? In this, how many diagonals? Just tell me how many diagonals this has.
Oh,
So what are the rule to get diagonals in this kind of like so 2 diagonals you have? You can clearly see these are 2 diagonals. Agree?
yes,
If
sir.
you have 4 vertices, then 2 diagonals, and 4 sides, then 2 diagonals. To form a diagonal, what is required? If this is this kind of objects, you joined any 2 vertex except adjacent vertex. Now, understand? Tell me how you will do that. If you have 5, then see, you can like figure out in different ways also. If you have like 4 sides, then you can write 2 diagonals. If you have 5-side pentagon, then how many diagonals you can form? See, you can join any except adjacent, agree? And form a triangle. You here also you can join any except adjacent from here. तो इसका रूल अभी हम ज्योमेट्री में पढ़ेंगे, अभी मत करो। जब ज्योमेट्री का पीएनसी करेंगे तो इसके पूरे रूल्स है। आई हैव पीडीएफ फॉर डिफरेंट रूल्स, तो वो थोड़े
So
बाद।
there's a formula for diagonals.
नो डायगोनल्स मेरे पास पूरे रूल्स है ना, मैं जस्ट गिव यू दोस। लाइक अभी क्या है कि मैं आई वांट टू डिराइव फार्मूला, अदरवाइज यू वोंट अंडरस्टैंड इफ यू राइट डायरेक्टली, इफ आई राइट फार्मूला। ठीक है, सो ये हो गया, ये हो गया, चलो ठीक है, ये ऑलमोस्ट हो ही गया। चलो लेट अस रिवाइज वन फटाफट एंड देन मूव अहेड। इसके पूरे रूल्स है, मे बी आई विल पुट द पीडीएफ आल्सो व्हाट वी गोइंग टू डू नेक्स्ट। अभी आज ही दे दूंगा। चलो अच्छा, 2-3 क्वेश्चन करके थोड़े से गेट यूज्ड टू हो जाओ। सो Priti, this is what, like, how many different paths A to D? Tell me.
So 4.
No, बेटा, यहाँ से शुरू कर किधर से जाए? How many ways A to B you can reach? 4, B to C 3,
Yeah.
C to D 3. So that's how you have to do. 4, no? 4.
Okay.
So you multiply because each index. Suppose you're going here to here, then to reach here to here you have 4 ways, no? 3 ways. If you're going this way, then again you have 3 ways. So that way you have to do it. You multiply all of them. Okay.
Okay.
So this express this into the in the form of this. What it is? Isn't this is 4 factorial, or 8 factorial? Understand? This is how you
Yes.
can write into. You just multiply 7, 6, 5, 4, 3, 2, 1, divide by 7, 6, 5, 4, 3, 2, 1. This value is what? 10 factorial. This value is 7 factorial. Agree?
Yes,
Now,
sir.
how will you change this? Like second question. This. Okay, so here you'll write like n factorial. Then you open it up such that you can get n minus 2 factorial. So it was n minus 1, n minus 2 factorial divided by n minus 2 factorial. This cancel out, so n minus 1.
Okay.
Okay. Now here this, list the permutations of the symbols P, Q, R, S taken at a time. So that you know anyway. Okay, 4-digit numbers, this at most once each, if there is no repetition. So 4-digit number 4P, like 7P4, agree? So when you say number is even, then you end up doing counting. So counting means like for unit place, how many options you have? 1, 2, 3. And then remaining 2 places you have this place you have options 6, this place you have option 5, or this place you have 6 options, this place you have 5 options. So any one of you can take. Okay. List the different terms of the 3 people that can be chosen from a squad of the 6 player. That is also fine, no? List 3. So matlab 6C3 you want, no? This is also you. It's just like this geometry. I have full documentation on geometry. So next class I'll do geometry. Chalo, acha, I'll take 2-3 more questions. Riddhi, I have A, B, C, D. Agree? I have to form 3 different letters. How? 3 different letters. How many different ways I could form 3 different letters? Okay? Tell me.
But so the repetition is counted or
When
like
repetitions is counted, like repetitions is there, then the normal ways is gone. You can't do by normal way, the way you do it. Agree? So you have to
yeah.
come up with other way. So you have to separate selection plus arrangement. So selections in this case, what is selections in this case? You can like whatever repeating, put constraint on that. Agree? So you can have 0A, you can have like 0A means no A's, then you can have 1A or you have 2 A's. Only these options you have. If A is
Yes, sir.
selected, If 0 A's are there, then you're selecting these three. So there's no selection ways because 3 out of 3 all will come. No?
Yeah.
B, C, D. Now arrangements of that is what? 3 factorial.
Yes, sir.
So when 0 A's are there, so the number of letters, 3-digit letters you can form with 3 factorial. If
Yeah.
1 A is there, then the other A for sure you won't take because you have two constraints of taking 1 A. Then remaining out of 3 you take 2. So 3C2. Okay. 3
Yes.
2. Now these all three are different. So arrangement is 3 factorial. If you take both A's, then you have to. If you take both A's, then you have to take only one from here. So 3C1. Then
One.
arrangement ways are what? 3 factorial divide by 2 factorial because 2 was same. Agree?
Yeah.
So if you try to write this into the proper formal ways, then first is 3 factorial, second is what? 3C1 is 1 into 3 factorial plus this is what? 3 into 3 factorial divided by 2 factorial. Understand?
Yes, sir.
So this one is what? 6. This one is what? 6. This one is what? 6 again, na? 18 ways. Understand?
Yes.
These kind of questions also there. If suppose I have A, B, C, D, and I have E, F, G. So how many different, these are the boys, these are the girls. You have to do seating arrangement such that no girls is together. Understand question?
Yes, sir.
What will do? You don't want girls to be together at all.
So you can like keep like 1 and 1. So keep 7 seats.
You can do this way. सीधे बेटा मेरे पास मतलब मैं like when the girls are not together you think this way. How many girls are there? 3, no?
Yes, sir.
You do seating arrangement of boys and create a space in between.
Yeah,
Okay.
sir.
So you have A, B, C, and another boy D here. Agree? So how many spaces you have? 1, 2, 3, 4, 5. So out of those 5 space, you can put these 3 girls, then they will never be together. Agree?
Yeah.
So arranging them is what? Is in 4 factorial
Yes, sir.
and choosing 3 place out of 5. So 5P3.
Yeah, because the arrangement also matters.
Yeah, arrangement matters. Order matters. If you do this here and this here, then it's different seating arrangements. Now, what was the constraint to girls not to be together? What is now? How many different ways and boys are not together? So then you
So,
create a space for these girls. So G1, G2, and then G3. Agree? Then 1, 2, 3, 4.
there are only 4 spaces.
4
So,
spaces. No like changing. So out of 3, 3 factorial. Out of 4, 4 factorial. Agree?
yeah.
So these are different ways and the boys are not there. Okay. So how many
Okay.
seating arrangement I want to like I can do when one girl and one this guy they want to sit together.
So D and E will become like a fixed one.
So then
And
1, 2, 3.
3,
This counted as 1, 4,
4,
5,
5,
6. 6
6.
factorial. They can flip their position into 2 factorial.
Yeah.
Okay. Done? समझ में आ रहा है ना?
Yes, sir.
So what did we learn today? What is the difference between P and C? This is basically selections only. This is selection plus arrangements. Agree? So what is NCR? That was n factorial divided by n minus r factorial into r factorial. What is NPR? Which is like n factorial divided by n minus r factorial only. So that is also NCR times r factorial. So n factorial is what? N factorial is n minus 1, n minus 2 till 1. Okay, n factorial. So this is n into n minus 1 factorial. You can write n minus 1, n minus 2 factorial, depending on what you want to write, how much you have to calculate. So NCR properties were there. If NC 0 you have, that is always going to be 1. NC 1, that is going to be always same as NC n minus 1, which is always n. NC2 is always n minus 1, 2 into 1. And NC3 is always n minus 1, n minus 2, 3, 2, 1. Okay. So that's how you can write it. Now the difference between permutation and combinations you have to find out first. Okay. So these are there now. ठीक है रिद्धि, यही था ना, और कुछ है इसमें? सिलेक्शन और
No, sir. I think
हाँ
you
इतना ही है
covered
ना.
it.
तो जस्ट आई विल गिव दिस टेक्स्ट बुक, ट्राई टू डू. एंड मैं अभी सब पूरा इसमें अपलोड कर देता हूँ पूरा प्रॉपर. मैंने IB AHL 11th 12th ग्रेड की टेक्स्ट बुक लेके करा है, जिससे थोड़ा स्लो जाता है. इसमें AMC के डॉक्यूमेंट्स आर वेरी डिफरेंट एंड आई हैव गिवन टेक्स्ट बुक आल्सो दैट आई यूज. सो दिस solutions also the textbook. So I'll put into the group, try to solve it. I'm going, someone has come to meet me. ठीक है. Okay, bye.